Today our topic is vertical translations. Our goal is, I understand what vertical translations look like in an equation, and you know how to graph them. So all of this unit, we're focusing on transformations. Okay, and a transformation is just a change. So we're looking at changes to y equals x squared. We're looking at changes to that parabola. So yesterday we looked at stretches, compressions, and reflections. Okay, so those are some of the transformations that can happen to y equals x squared. Today we're going to take a look at vertical translations. Be careful you don't mix up the word translation with transformation. So all of these different changes are called transformations, the whole group, but the specific one we're looking at today is vertical translations. All right, so let's take a look at what happens with translations. So for each of the following, in example 1 here, we're going to complete the table of values, plot the points from the table onto the graph, and draw the parabola through the plotted points. So similar to what we did yesterday, except with a new equation here. So in this case, we're going to substitute -2 in where the x is here. So -2 squared plus 3. And -2 squared is going to give me 4, positive 4. And then plus 3 is going to give me 7. All right, so we're going to do that calculation for each of these. I'm not going to show the calculation each time. I'll just write down the results here, and you guys can copy these down. As I mentioned yesterday, we're going to use the tables so we can first get a look at what these parabolas look like, but eventually we want to get to the point where we don't have to use the table of values at all. Okay, so I'm going to plot these points on the grid, so -2, 7, -1, 4, 0, 3, so I'm right there. And remember, the next one here is 1, 4. And so you can see that that's where the parabola turns. So that must mean that there's a point here. And we call these 2 points symmetrical pairs. And these 2 points would be symmetrical pairs as well, because they're the opposite point on the other side of the axis of symmetry on the other side of the vertex. All right, so I'll go ahead and draw my curve for these ones. This is going to go like that, and this is going to go like that. Okay, so that's what y equals x squared plus 3 looks like. But down below here, it says sketch the y equals x squared parabola on the same grid. So hopefully you're getting better at drawing y equals x squared. So we've got 0, 0. And we talked about the step pattern, so over 1, up 1. Over 1, up 3. 1, 2, 3. And over 1, up 5. 1, 2, 3, 4, 5. And then the same points on the other side of the vertex. And you guys are going to learn this parabola stuff so well that you might be able to bring this stuff out at parties. Be a lot of fun, explaining how to work with parabolas. So that is the parabola y equals x squared. Okay, so we've got our 2 parabolas there. we can see how the original parabola y equals x squared changed to y equals x squared plus 3. So the question down below here is, how did the vertex change from y equals x squared to y equals x squared plus 3? So you can see that the vertex moved from here to here. So vertex changed from 0, 0 to, and that coordinate there is 0, 3 in the new parabola, so 0, 3. Okay, and then how does the axis of symmetry change? So remember, for axis of symmetry, we're talking about the line that comes right down through the middle of the parabola, through the vertex. All right, and when we look at that axis of symmetry, it's the same axis of symmetry for both the parabolas. Okay? So for this one, we're going to say axis of symmetry does not change. And the equation for that axis of symmetry is x equals 0. Because that's a line that cuts the x-axis at 0. Okay, so when we're looking at that plus 3 that's added on the end, okay, we're going to use Q to represent that. Okay, so the Q moves the parabola up or down. And as we saw there, Q was positive. So if Q is positive, we saw that the parabola moved up. And I'm sure you guys can figure out what's going to happen when it's negative. In that case, it's going to move down. All right, so let's use what we found there to try and do the next one here. Okay, so y equals x squared or minus 1. So at this point, we are going to say no to a table of values. Table of values are great, don't get me wrong, but when we learn shortcuts to graph these items, it makes it much easier. It's just like with lines. When we first learned about lines, we did do a table of values, but then we learned how to use the slope and the y-intercept to graph it, so we didn't need our table of values anymore. So what we need to identify for this parabola is the vertex and the step pattern. Okay, so the vertex, we saw that the vertex was 0, 3 when it was y equals x squared plus 3. So here the vertex is going to be 0, minus 1. And the step pattern is going to be 1, 3, 5. There's no number multiplying out in front of the x squared, so it's the same old step pattern that we're used to. So to graph this one, I go to 0, negative 1. Here's my vertex. And then I'm going to count my step pattern from there. So over 1, up 1, over 1, up 3, over 1, up 1, 2, 3, 4, 5. All right, so we've got our points on the right-hand side there. We'll do our mirror points on the other side. And there's our parabola. For y equals x squared minus 1. So hopefully you can see the importance of those two pieces of information. If you know the vertex for your parabola and you know the step pattern, then you can graph it very easily. All right, let's jump down to these guys. So for these ones, we're going to do just what we did up above. We're going to state the vertex, and we're going to state the new step pattern. So vertex and step pattern. Okay, so we have y equals 3x squared minus 8. So remember, the number on the end here affects the vertex. So the vertex is going to be 0, negative 8. And yesterday we talked about how the number in front changes the step pattern. So 1, 3, 5, those numbers are going to get multiplied by that 3 that's out in front. So the new step pattern is going to be 3, 9, 15. So let's go ahead and plot this. So the vertex is at 0, negative 8. So there's my vertex. And then from there, I count the step pattern. So over 1 up 3, 1, 2, 3. And then from that point, over 1 and up 9, 1, 2, 3, 4, 5, 6, 7. And we'll just estimate where this is. 8, 9. So that's about there. And then on the other side of the vertex, I'll do the other 2 points here. And when it comes to the step pattern, you don't have to, like, I'm not going to count the next 15 up for the next point. What you do is you plot all the points that you can fit on the parabola and then or on the grid, and then you go ahead and you sketch your parabola through those. So I'll come up here. Okay, so you can see how stretched this parabola is. It's stretched by a factor of 3. So this parabola is y equals 3x squared minus 8. All right, let's take a look at the second one here. Okay, so for this guy, the vertex is going to be 0 and 2 because of that 2 on the end. The step pattern is normally 1, 3, 5, but there's a negative out in front. So it's kind of like we're multiplying by negative 1, but basically the step pattern changes to negative 1, negative 3, and negative 5. So we'll start with the vertex. The vertex is at 0, 2. And then my step pattern is over 1, down 1, over 1, down 1, 2, 3, and over 1, down 5, 1, 2, 3, 4, 5. And then same thing on the other side. And then we can draw our parabola through those points. So you can see that red parabola, it gets reflected because of the negative out in front, so it's turned upside down, and then the vertex moves up 2. The whole parabola moves up 2 after that. So that's what the parabola looks like for y equals negative x squared plus 2. Okay, so you're going to do some practice on this stuff, and we'll see you tomorrow.